Here we'll look at radicals, which is just a word to mean square roots or cube roots or higher roots. We say the square root of a is equal to b if b squared is equal to a and b is bigger or equal to 0. So essentially it's what number squared is this number. And we can expand on this for higher roots as well. The nth root of a equal to b means b to the n is equal to a. When we're dealing with just square roots, we don't put the index of the 2 on the root, but anything higher we will. So let's look at a few examples of this. The square root of 36. Well, the square root of 36 is 6, since 6 squared is equal to 36. What about the square root of negative 36? Well, we know 6 squared is positive 36, and we also know that negative 6 squared is also positive 36. And in fact, nothing here, because if the root was positive, a positive times a positive is a positive. If the root's negative, a negative times a negative is a positive. So square roots of negative numbers do not exist. The cube root of 27 would be equal to 3, because 3 cubed, 3 times 3 times 3, is equal to 27. The cube root of negative 27 is negative 3, since negative 3 cubed is equal to negative 27. In general, if you're taking a root of an even index, so the square root, the fourth root, the sixth root, you can't take those roots of a negative number, but you can take odd roots of a negative number. So now that we have a little bit of this, let's look at some properties of these radicals. Our first property looks at products. If I want to take a root of any index, any root of a product AB, it's the same thing as taking the root of each of those numbers and multiplying them. So the nth root of AB is the nth root of A times the nth root of B. And since there's one for products, there's also one for quotients. The nth root of A divided by B is the nth root of A over the nth root of B, provided B is not equal to 0. So if I want to take a root of a fraction, I can just take the root of the top divided by the root of the bottom. A root of a root, so the mth root of the nth root of A is the mnth root of A. So if I want to take the root of a root, I can multiply the index of that root. The next one, the nth root of A to the n is the absolute value of A, provided that n is even. So as an example, as we did earlier, the square root of 36, negative 6 times negative 6 is also 36, but whenever we're taking roots, we always consider the positive one. The nth root of A to the n is just A if n is odd. So if I'm taking something like a cube root, I don't have to worry about the absolute value. Like we did earlier, the cube root of negative 27 was negative 3. Now that we've looked at some of these properties, let's do some examples of using them. The cube root of x to the 7th. Well, I can rewrite x to the 7th as x cubed times x cubed times x. And then my property of product says this is the same thing as the cube root of x cubed times the cube root of x cubed times the cube root of x. My last property says that the cube root of x cubed is just x times the cube root of x, or x squared, cube root of x. Another one, the fourth root of 81, x to the 8th, y to the 4th. This can be the fourth root of 81 times the fourth root of x to the 8th times the fourth root of y to the 4th. I can further break up x to the 8th as x to the 4th times x to the 4th. So that gives me this. The fourth root of 81 is 3. Since 4 is even, the fourth root of x to the 4th is the absolute value of x times the absolute value of x. The fourth root of y to the 4th is the absolute value of y. So I have 3 times the absolute value of x squared y. Another thing we can do with these is combine them. So one of the most common mistakes that we have in square roots is saying that the square root of a plus b is equal to the square root of a plus the square root of b. But this is not true. As an example, I'm going to let a be equal to 3, or a be equal to 9, sorry, and b equal to 16. If I look at the square root of 9 plus 16, well, 9 plus 16 is 25. That gives me 5. However, the square root of 9 plus the square root of 16, the square root of 9 is 3, the square root of 16 is 4, and here's 7. So we need to make sure we don't break this up over addition. So let's look at adding these, the square root of 32 plus the square root of 200. We can't write this as the square root of 32 plus 200, but we can simplify things. I'm going to rewrite 32 as 16 times 2 and rewrite 200 as 100 times 2. The square root of 16 is 4, and the square root of 100 is 10. And now since these both have a square root of 2, I can just add the numbers in front. 4 plus 10 is 14, square root of 2. Another one, the square root of 49x minus the square root of x cubed. I'm specifically saying x is greater than 0, so I don't have to worry about absolute values here. I'm going to rewrite this as the square root of 49 times the square root of x minus the square root of x squared times the square root of x, since x cubed is x squared x. So I have 7 square root of x minus x square root of x. Here I can kind of factor out the square root of x and rewrite this as 7 minus x square root of x. Let's look at one last one. I can't break up my root, but I can see that everything under here has a 4 in common. This is the same thing as 4 times x squared plus 2. Well, that would be the square root of 4 times the square root of x squared plus 2. And the square root of 4 is 2. So I was able to simplify this some.